Let's take a look at this example. I'm going to start solving this problem from redrawing the circuit because this circuit can look a little bit complex. Again, I'm going to mark 2 points. Okay, we have 2 nodes over here. We have node A and node B. Okay, again, I prefer to keep the voltage source on the left side of my diagram. That's why I'm going to draw over here my voltage source. And I have 2 points, point A and I have point B. Resistor R1 is connected to point A and point B. That's why I'm going to draw resistor R1 over here. And resistor 2 is connected to point A. After that is also connected to R3. And R3 is connected to point B. Okay, so this is my R2 and this is my R3. So again, as you can see, this diagram is looking much easier than the top one. So what I'm going to do first, please notice that we have given voltage across resistor R1. Voltage across resistor R1 is in parallel with the voltage source. So it means that V1 is equal to the voltage source. And this is very important to write this down. V1 is equal voltage source. And we have already voltage source, right? Which is equal simply 60 volts, right? Next, I'm going to combine these 2 resistors together, okay, because they're in series. So I can add them up. So my R23 is equal R2 plus R3, where R2 is equal 6 kiloohms plus R3, 2 kiloohms is equal 8 kiloohms. Okay, so this is the total resistance of these 2 resistors. Now, what we're supposed to find next? We're supposed to find the current which goes through the resistor R23. Okay, so I2 is equal to I3 and this is equal I23. Okay, I2 is equal to I3 because these 2 resistors are in series. Okay, so I'm supposed to write that I2 is equal to I3 is equal I23 is equal voltage source over R23. Okay, voltage source which is applied to the circuit is going to appear across these 2 resistors. So this voltage divided by the total resistance of these 2 resistors is going to give me the current which will go through these 2 resistors. So a voltage source 60 volts over 8 kiloohms gives me 7.5 milliamps. Okay, so I found the current which goes through these 2 resistors. Next, we can find V2. V2 is equal I2 times R2. I2 is equal 7.5 milliamps times R2, which is equal 6 kiloohms. This is equal 45 volts. Next, we're supposed to find V3. V3 is equal I3 times R3, which is equal 7.5 milliamps times R3, which is equal 2 kiloohms. This is equal 15 volts. Okay. Next, in order to verify our answers, we're supposed to simply add these two voltages together. So voltage source is equal V23 is equal V2 plus V3. So I have 45 volts plus 15 volts. This is equal 60 volts. So as you can see, the value of my voltage source, which we found at the beginning, is equal to 60 volts again. So it means that our calculations up to this point are okay. So we found V2, we found V3. Next, we are going to find total current. Please notice that we found voltage source. Okay, voltage source is equal to 60 volts, and we have given R total. So you can find very easy I total. I total is equal to voltage source over R total, where voltage source is equal to 60 volts over R total, 5 kiloohms. This is equal 12 milliamps. Okay, so this is my I total. We have I2, right? I2, which is equal basically I3. We have I total, so we can find I1. I1 is nothing else, just the difference of I total, and we can say I23 or I2 or I3. So this is equal I total 12 milliamps minus I23, and we found that this is equal 7.5 milliamps. So this is equal 4.5 milliamps. Okay, let me just show this situation on the diagram. So we have I total and we have current I23. So I total minus I23, this is comma, will give me I1. Okay, so this is basically what I have calculated just seconds ago. So we have I total. Next, we have I1, and we can find R1. R1 is equal voltage across resistor R1 over I1, where V1 is equal to the voltage source is given. We have 60 volts over I1, 4.5 milliamps. So I have 60 volts divided by 4.5 milliamps is equal 13.33 kiloohms. Okay, so this is the resistance of resistor R1. Next, we can find the powers. P total is equal I total times voltage source. I total is equal 12 milliamps times voltage source 60 volts. So P total is equal 720 milliwatts. Okay, so this is the total power in my circuit. P1. Okay, so I have P1 is equal I1 square times resistor R1. Okay, so I1 is equal 4.5 milliamps. We have to raise this to the second power times R1, and R1 is equal 13.33 kiloohms. This is equal 269.93 milliwatts. Okay, so this is the power at resistor R1. Next, we're supposed to find the power at resistor R2. So if P2 is equal I2 raised to the second power times R2, which is equal, I2 we found is 7.5 milliamps raised to the second power times R2, which is equal 6 kiloohms. This is equal 337.5 milliwatts. Okay, so this is my power at resistor R2. Next, we're supposed to find P3. P3 is equal I3 raised to the second power times R3, which is equal 7.5 milliamps raised to the second power times R3, 2 kiloohms. This is equal 112.5 milliwatts. Okay, so we found all powers. Now we're supposed to verify if our answers are correct. We're supposed to add all these three powers together. So if P total is equal P1 plus P2 plus P3, which is equal 269.93 milliwatts plus 337.5 milliwatts plus 112.5 milliwatts. This is equal 719.93 milliwatts. Okay, let me remind you that before we found P total equal 720 milliwatts. Okay, so as you can see, these two values are very close to each other, so it means that our calculations are correct, and we can say that the problem is solved.